Hello, I'm Steve Lewis. Welcome to the fourth module of Applied Statistics for Healthcare Data Analysis. This course is funded by a grant from the United States Department of Labor and uses a curriculum developed by Carnegie Mellon University. In the last module, we began talking about the principles of probability. These are a conceptual bridge between the exploratory analysis we did on the data drawn from our population of interest and the tests of inference we want to perform on the statistics produced by that analysis. In the last conversation, we talked about two particular points. The first was the idea that if we could assume a random variable was distributed normally, we could also assume that the probabilities associated with the pattern of that distribution were normally distributed. I think that's probably somewhat intuitive, but it's an important concept going forward. The second idea that we worked with was that for a variable where we did not know the theoretical probability, in other words, if we were dealing with empirical probability, if, hypothetically, we ran a very large number of trials, independent of each other and of equal size, and recorded the values that emerged from those trials, we could create a relative frequency distribution, which would be a probability distribution of outcomes for that variable, approaching or approximating the theoretical probability distribution associated with that variable. We're going to take those two ideas forward and start talking about a concept that is used in essentially every test of inference that we are going to make going forward. First, I want to make sure that we understand the distinction between a measure relating to a sample and a measure relating to a population. Sample measures we call statistics. So, for a categorical variable, we can have a sample statistic of a proportion and the standard deviation or spread of that proportion. Or for a continuous or quantitative variable, we can have a statistic as a measure of a sample mean and a sample standard deviation as a measure of spread of that sample. At the level of the population, the corresponding measures are characterized as parameters, so that we can have, for a categorical variable, a parameter of the population proportion and standard deviation of that proportion, or for a continuous or quantitative variable, a parameter of the population mean and standard deviation. So today we're going to be talking about the relationships between statistics at the level of a sample and their corresponding parameters at the level of the population. And we need to start by thinking in terms of a very central concept that we'll be using going forward in all the tests of inference that we will be talking about in this course. And that's what's called the central limit theorem. The central limit theorem states that if you took a very, very large number of trials of a particular variable, the distribution of the means of those trials would be normal. In other words, the mean of those means and the standard deviation of those means would have a normal distribution of those values around that mean corresponding to what they would be in a normal distribution of the events in a sample. That if you have a large enough number of trials, the means of those trials are going to distribute themselves normally. That idea has very, very central implications going forward, because what it will allow us to do then is examine the probability that the particular mean we got in our sample, or the particular proportion that we got in our sample, because it applies to proportion as well. It allows us to examine the probability that that mean or that proportion matches that of the population as a whole. That's why the central limit theorem is, if you will, the keystone of the bridge that the probability principles allow us to create between the statistics that we generated in our exploratory analysis and the various tests of inference that we will be making going forward. In the next module, we will be talking about those various tools, those various tests of inference that we will be making. But for now, I want to be sure that everyone understands the concept that hypothetically or conceptually, there exists an idea of a distribution of the means of a large number of samples. We in fact do not take a large number of samples. We have to work with only one sample, typically. But by having the idea that there is a normally distributed distribution of the means of a large number of samples, we are able to perform a variety of tests of inference appropriate to the nature of the research question that we're asking and the nature of the variables we're working with, that allow us to compare our one sample mean or our one sample proportion with a hypothetical sampling distribution that then provides an approximation of the population probabilities associated with that same variable. I'm going to stop at this point and give you a chance to work through the examples in the course materials, and I hope that if we have questions around this particular topic, we can address them very quickly before we get into the section on inference. This is, as both the course materials point out, and as my own experience points out in using inferential tools, a key idea that we need to make sure we do fully understand. Thanks very much, and I look forward to talking to you next time.